Good afternoon. I think I will speak in Chinese. So first of all, thank you very much for inviting Mesosphere to Yunqi Conference to introduce our products, to introduce Mesosphere. And I think this is really a good weather because we have so many clouds here for the cloud conference, but we also suffer from traffic jam. I want to make a quick survey to see the mix of the audience, so that I can make my presentation more targeted. Raise your hand if you have heard about Mesosphere. Raise your hand if you have heard about Mesosphere. Quite a few. Nice. How about mesos? Raise your hand if you have heard about mesos. Anyone heard about DCOS? Very few then. How many of you have participated in the Mesos community as a developer? How many are developers? Raise your hand if you're a developer. Last question. How many of you are architects? So I think I could go more technical since we have a very professional audience. So because I have like 30 minutes, does that include QA? But I will give you my contact so you can contact me. Now I have some keywords here. Modern apps. What is modern apps? So we are always talking about microservices. We talk about containers, and the modern apps are the applications based on container technologies and also across the hybrid cloud. We working also together with Ali Cloud, so we've delivered a solution based on hybrid cloud. So I'm not really going to talk a lot about our company, but when our founder, Benej, one of our founders, he open sourced the Apache Mesos. Another is DCOS. So this is the introduction, because as I said, we have a very professional audience. I will go quicker here, and then I'll introduce Apache Mesos, Marathon, and Mesos DCOS. And then I will talk about container orchestration with DCOS, introduction, modern apps, and the data services on DCOS. And then I will also compare DCOS to other container technologies, like Docker's Kubernetes that we've heard about in the morning. So I think this is a page so familiar to you. This is the virtual machines matrix. Start time is compared with the virtual machines. Container has a much shorter start time and shorter stop time and higher workload density. And if you are working on lifecycle management, ops and maintenance and the design, if you cannot start and stop your applications fast enough, it will result in disruption of your delivery and then workload density. So the higher the density, the higher the efficiency. And when we talk about the benefits and the challenges of containers, let's see a list. This clicker is really killing me. The container benefits. It can improve the developer productivity, and I think as a developer you can really experience that it's very fast. You can one click to deploy the whole set of applications, and it also helps to increase the infrastructure efficiency. When you're using IaaS infrastructure as a service, in terms of the call of the resources, the efficiency is also much higher. And then is operational agility. it's faster and more agile. And when you develop, test, it is all integrated. Challenges. For many people, when they're using container, the greatest challenge is that it's new knowledge, it's new kind of know-how. It raises issues like security, networking, storage, adaptability, and then it costs you time. This is the mainstream container technologies now. One is Docker. I actually visited the Docker and Ali's strategic partnership. We expect in the future we can also become a partner with Ali Cloud. Docker runtime and the Docker engine is more familiar, and also Docker Swarm. On the right side, you can see Mesos. Mesos, I think I just asked and found that everyone knows Mesos. It's really on the resource management and the resource core. So in the heterogeneous structures, whether it is virtual, non-virtual resources or public cloud resources, I can put it on one machine and the management and the Mesos is really help to in terms of CPU, network, RAM to manage the resources easily. And also the DCOS it is on the monitoring, operation, maintenance, and management toolset. This is DCOS as relationship with Mesos. And the Kubernetes for DCOS, we are not really competitors. Many people say that, and also a lot of online articles say that DCOS, Mesos are direct competitors with Kubernetes. But I don't know if you realize that 2 months ago on the LA Mesos conference, Google also has a representative from Kubernetes to announce collaborations with Mesos and DCOS, and we feel that it is it's a framework for container orchestration. So on it, you can have KBS, you have Marathon, you have Spark, Kafka. So these I would explain later. And also around it, we have cloud supplier vendors like Prenda, Nomad, CoreOS, OpenStack, Rancher, etc. They're doing the building based on DCOS, Kubernetes, and Mesos. So this is the landscape. Life cycle of container adaptation. So I'll go quicker on this. When you learn Docker, what's the learning curve of Docker? It's like basically you take a laptop, install Docker, build Docker images, run Docker run, and then an app sits there. And then your applications will be running. This is the process of exploration. And then the next step is learn. Because you've explored, then you have to learn and put it in your own environment. So in the dev test environment, you will do container orchestration, and then you could use Kubernetes, Docker, Mesos, DCOS, and then you have to manage the entire life cycle of the app: start, stop, operation, and maintenance. And also add on storage and the networking. You want is it external or local storage, and then networking. Of course, there is CNI-based networking, so you can do adaptations. The thirdly is integration. When you have explore experience, you have the learn, you have depth and test experience, you can then start production. And then when we talk about production, security comes on the top of the agenda. Companies are very careful about the security and the monitoring, and the leaders are very concerned about auditing. Then it will be applied on CI/CD and launch. And also what we call is stateful services, because when I didn't see many people raise your hands when I asked about the DCOS question. I don't know if you know our Snap, Kafka's, and Cassandra, how they use containerized deployment. I think you will use Kubernetes to deploy, but how to operate and maintain this at the enterprise level. So you will consider about the stateful services. Can these stateful services be deployed on framework based on containers? And on the bottom is the legacy systems. What we call is basic traditional applications. So this is a linear process. Of course, you can also have a swearing process as well. So, of course, for container as a service CAS, people will say that whether it's in competition with IaaS or PaaS, I think maybe in the future, CAS will replace the two combined. So, building blocks of container as a service, you have to have a PC, right? On the left, in a DevOps, you have a Docker for Mac or PC. Then you have a source code control, like GitLab, to use this to manage your code. And then CI/CD, since you are to build a container image, then you have to use container registers to manage it. And then you have to consider the production environment, how to bring the Docker images and these standardized based images deployed on your production environment, and to do orchestration of your containers based on your current infrastructure, and also a data center or cloud. If a company leaves data, then basically it lost its lifeline. And then how you connect it, we could through CI/CD to connect all these dots. So you can use CI/CD to connect development, production, container orchestration, operation, and maintenance. Next, I will introduce Mesos, because I saw just now only a small group of people know about Mesos. So I will quickly introduce Mesos, Apache Mesos. This glitch doesn't really work very well. This clicker doesn't really work very well. So I will now talk about Apache Mesos or its history. I mentioned that around 2010 we developed Apache Mesos project. Our founder, Bern Madge, and he in 2013. There's a Mesosphere company was established in Silicon Valley in California, and then they went through round C funding. From receiving funding from Microsoft, dozens of millions funding, and in 2016, this company open sourced its DCOS product. You can on the right side DCOS. This was open sourced in April 2016. Almost 60 companies participated in the first batch of in the projects, including community incubation. So on the bottom, So in the whole process, the earlier user of Mesos is Twitter. They use Mesos to solve a lot of parallel challenges and a lot of complications. And then Airbnb is the early users to use Mesos. Meanwhile, Mesosphere's the CEO, Floor, he's actually come from Airbnb. So in the early stage, they also work together with Twitter and PayPal, Netflix, and also iQIYI in China, Visa. This and also Microsoft Azure. So they gradually has a continuous iteration from public cloud and dedicated cloud.
然后这边就是 APAC Mesos 啊，这个我就是稍微快点啊，因为 APAC Mesos 这边它有3个问题，第一个是能够真正的让企业实现电子化。
First of all, it can pull in all its resources. For example, the heterogeneous resources will realize the pulling. And also it can engineer for small to very large scale from day one. For example, your cluster and your data center, it can complete this whole process. And also it can help you support the existing and future workloads.
然后它是怎么做到呢？我们叫这个2层调度。第一层调度
So how does it realize it?
Master Agent 的这种调度。
We call it two-level scheduling. The first level is Mesos master and agent. So the master agent are like peers. So the master will manage the resources. And also we have some resources isolation. For example, you deployed a lot of jobs or tasks. They will exist in isolation. And the second level, we call it Mesos framework. It has scheduler and executor. Scheduler will help you to distribute the tasks, and executor will execute. For example, here we have Spark, Cassandra, and Container on the upper level. We call it framework. And if we give examples, what's the special in it? The special thing is it can isolate the task distribution and resource isolation. For example, the Cassandra is upgrading; it will not affect the resource, and also it will not affect the Spark framework. The two levels of scheduling is different from Doc Swarm and Kubernetes. And this is a marathon. I think you all heard about marathon. And this is a pass based on Mesosphere. It can, for example, API, CLI, or the other tools, it can help to do the orchestration framework. On this slide, as I just mentioned, why this is based on the hybrid cloud. Actually, no matter it's Ali Cloud or CentOS provided by Amazon or for on-premise, no matter what kind of, no matter it's virtual or non-virtual, so we can have the scheduling based on hybrid clouds. But for some extreme cases, so if you do the hybrid cloud, you can put one data center in the US and one data center in China. Is it okay? I said, of course, in extreme scenario, it is okay, but it will have some latency problems. So how can we avoid this network latency? This is the key issue. And Mesosphere will provide the enterprise level solutions. And then another upper level is the Modernize. And on this slide, from bottom up, we have three standards in promotion. One is OCI and CNI and CSI. Maybe you don't know about CSI. CSI is Mesosphere and Google co-leading standard based on container. So these three standards are under. Actually, now we are facilitating the application of these three standards. And the separate package is based on the framework. So you, just one click, you can install these packages on the left of the slide is a dashboard. You can use this, and you can see the resource utilization of this dashboard, like the CPU and so on. And on the right is the one-click installation of those modern apps. And for DCNOS model, what's the difference between traditional approach and Mesosphere DCOS approach? On the left has many snowflakes, so we have some redundant resources and we don't have a pool of resources. But on the right, if we use the Mesos DCOS, we have a hybrid resource pool. So no matter it's stateful or stateless, it can, based on Kubernetes or Marathon, they can use a unified resource pool to use it. So under the industry standard, it can provide 3 to 4 folds improvement of the resource utilization. So when you improve the efficiency, the computing will be more accurate, and also it can help you to save the energy consumption. Container operation. So we support Docker, UCR, which is a universal container. It can support Docker and also support containers based on OCI. And also the apps based on different language, they are all supported. And the second is container lifecycle management. It's about the container lifecycle management. We have fine-grained placement rules. We have a fair sharing approach to help you find the computing or storage or network resources for your application. This is one of our unique features. DCOS also support pods. Failure detection recover, we are similar. For example, if you restart or upgrade the agent, it will not affect the workload. Monitoring and troubleshooting. We can use SSL login or share a COI to do the troubleshooting and the monitoring. Container networking. We also use the CNI approach to do the mapping. On the left, the challenge is before the containers and the microservices, you can see the architecture is like on the left, but after the containers and the microservice, the capex increases exponentially, and OPEX around allow B programmability. So what are the networking requirements? First, of course, is the connectivity. When you orchestrate a container, can we connect it? And also, can you discover the service? And the third requirement is load balancing. no matter it's east to west or north and south, and can it detect or remove the failed apps or nodes? And the fourth requirement is service registration, or can it realize the automatic updating container network information? So how we address to these requirements? In connectivity, we use IP per container, and we also use host or bridge networking. I think maybe in this aspect we are all similar. For service discovery wise, we have VIP. I don't know if you know about VIP, and then we have DNS, and we have the Mesos DNS. Also, you can use external DNS. For load balancer, it has L4, L7, east, west, north, south, south. It can realize automatic load balancing. For service registration, you don't need manual interruption. You just it can realize automatic registration. For container storage, what are the challenges? So many applications. It could be a local storage, external storage, or external storage. So based on different demands, it is a very complicated process compared with the traditional approach. So what do we do in DCOS? Our difference with Kubernetes is we are using the local disk. And also we adopt the CSI standard. We have blocked one layer of storage pool. So you can use the CSI standard to adapt to your local storage, internal storage, and external storage. 我们是企业跟企业级挂的比较多的，比如说我们跟 HPE 啊，包括戴尔啊，他们去做相关的一个存储一个集成，这是。And our storage integration is more with like HP or Dell. 然后就是安全这边了，安全实际上是。Another thing is security. 因为大家都是通过 runtime 这种 GeoCyber Docker runtime 这种方式。We use the runtime to deploy Docker. 在这里面大家说的最多的就是我一个 host 上 Docker runtime 我 Q 掉以后，这个安不安全？ So the security is a very important issue. So you can have different solutions. You can have your own solution, have your own isolation. But what do we do? 首先是我们是这个叫 authentication 这层，我们通过
authentication layer we use LDAP or single sign-on to guarantee your access security. For authorization, we use access control and ACL. Also, we use extensible identity. And for secure audit trial, we use tracing and logging to do the audit. Secrets. This is one of our highlights. In applications, you need to do like the user password or the sensitive information encryption. And it exists in the system in the form of variants. We call it secrets. And for other layer, and here we can see it says containers don't run as root.
actually is based on the human design. And for SSL encrypted and public-private agent architecture, actually they are similar with the other platform capabilities. We have high availability. Many people ask why we should choose DCOS. Actually, we are enterprise level, and also we are a user-proven platform. Also, we use N+1 to do HA, and we use Zookeeper to do the information storage. And deployment aspect, also we do the consistent deployment. You can choose different operating systems, and we officially support CentOS. And for the UI, CLI, AWS CloudFormation, we also have the tools similar with AWS CloudFormation. And for HP OneView, we also do it a lot. We have the collaboration with HPE. So operation, we can expand our cluster very easily. Our Verizon has reached about 160,000 machines. This is the largest in the world.
And in China, the largest number is 10,000 physical servers. There's no downtime. So whether it is master sweep or framework, when they're updating, they will normally they will have no downtime. So normally they will have no downtime. And also for monitoring and troubleshooting, so mostly it is accessed through logging to container to do troubleshooting, so nothing that different. And data services on DCOS. For modern apps, this is our current. This is the current data stores and analytics engines that we support now. And for the challenges, as I said, I have Hadoop, I have Kafka, I have Stop. So I have all of these data stores and analytics engines. Why do I have to use Mesos? Because if you have to do a deployment, then you have to deploy them one by one. And also for operating data services, manual and error prone. So you have to do ops and maintenance for every single one of them. And also infrastructure silos with low utilization. There is not that many connectivities. So whether it is human resource cost or time, and it could also be very time consuming. And also, why stateful data services on DSSOS? As I said, using Mesos, you can do one-click deployment. It's an aggregation-based solution. It's like a cluster Spark. And in terms of operation, why it can simplify the operations? Because it can upgrade the runtime software. It can also update the runtime application settings. And all the operations and maintenance is automatic. You can do scale in and scale out. You can do elastic. You can do elastic stretch with that as well. And the elastic data infrastructure. I talked to a lot of customers. They say that if I use your product, all of my physical hardware will be managed by your solution. No, our layer is on top of the OS layer. So under the OS, whether it is hardware or software, what is it? It's physical machines or VM, you still have to use it. The power management and the physical database management still maintain the same. So maybe through Meso's configuration tools, it can help to manage, but it's not a direct management over these physical equipment. And also, this is a SMAP. I don't know if you have idea about that. It is an end-to-end from the collection of the information to feeds, analytics, storage, reactive app, back to the app. The entire life cycle include Kafka, Spark, Cassandra, and AKKA. So first, it's a linear deployment to achieve SMAP. And when I was explaining to my customer that SMAP is cool, it can do a lot of things, but it doesn't mean that the DCOS can directly deploy a SMAP. It is deploy on these different steps and then configure them. And this is I think we have over 50 services made for enterprises DCOS, including big data and AI. You can quickly configure and deploy. And also, let's look at the DCOS compared to container orchestration. So the greatest difference you can see is from bottom to top. So hardware, then runtime. It is based on, it could be either DC or cloud. And then you have runtime, and then you have resource management. Because any innovation cannot be achieved without proper resource management, and also microservice. And then on top of that, you have container orchestration and the data service orchestration. And the big pool, you cannot to continue to segment, but you can draw like a shared pool for the system space. And on the right hand, monolithic scheduling, it's a one single layer call, and two level scheduling, and a monolith. And the monolithic scheduling is very different in terms of the dev and ops. And also for the microservices, the two parts are quite similar. They can both do microservices architecture, but you have to do your own deployment. And also, we provide a platform, not really functions based on your own apps. And also, for data services, I think Kubernetes, you know it very well. You can use it to do Spark and Kafka, no problem. But as I say, our difference is really the difference between two-level scheduling and the monolithic scheduling. So this is the open source page for DOS.io. You can check this out. And you can also ask questions on the page. On the right are the many open source and certified stateful services. So last page for Mesosphere, why we have certain advantages. First, we are open source support. We are, of course, we are major support force to the open source. We have unmatched technologies, DCOS, so we developed it in-house. We have also many experts on distributed systems, not only on DCOS containers, but also on network. We also do top layer ecosystem, these stateful services like Spark and Kafka. Many people ask me that, does that mean you can do everything? You can also manage the Spark. As I said, that we can manage, but we cannot solve everything because we are not a Spark expert, but we can maintain an ecosystem and we can deliver the question to the Spark community. I don't know if I use up all my time. Thank you for Sam's sharing. We'll have a QA session. If you have any questions. So in terms of container application, I think stateful services is a pain point. And on this regard, Mesos and Kubernetes, they have different solutions. And is there any difference on the performance? If I want to choose, I may choose one maybe with higher utilization of the hardware. I think it's a little bit difficult to answer because maybe it's from different dimensions. For starters, I think we are quicker than Kubernetes because you can see our universe. One click, then you can install. So I think we have lower learning cost. And also, however, on the deepening and the operation and maintenance, well, from the development of Kubernetes, they have a larger ecosystem and more participants and more completed functions. In terms of best practice and case deployment and production authentication, I think Mesos and DCOS do more. Doesn't mean do better, but we do more. We use a lot of Sparks and Hadoop on DCOS, but I think that Kubernetes will have very good development in the future. So that's why we include Kubernetes as our container orchestration method. So maybe from different angles, but I think that Kubernetes can, in terms of functionality and utilization, could be a very good choice, but it is not in conflict with Kubernetes. Okay. And the Kubernetes can manage the resources. But if you have like Amazon's and Google's layers, how, as I know, Amazon has EC2, Elastic Cloud 2. How can you, a container 2, do you have to provide account? Like you have to use your Google account, you have to use your Amazon account. So I said that the prerequisite is that we are Amazon or Ali Cloud based OS. Like CentOS, if you have to access it, it depends on what you want to do. If it is IP access, then you don't need an account and password. And however, if you want to look at the auto scaling, like Ali 10, Amazon 10 servers, and I have to scale to 100 on Ali, 100 to Amazon. Then you have, for such elastic scaling, then you have to use API access with account numbers and password. And we will provide you with the tools to automatically orchestrate, deploy the Mesos as well as the applications.
我提供了不同的账号给你，然后我现在有需求，我的业务量增加，
对，
我就要 scale up 它一些东西，对不对？
这个问题非常好，就是这个是因为那个时间关系我就没讲。我们有一个叫 auto scaling 的一个功能，就相当于说我可以根据你设定但是应用是你要看它需不需要资源，它有好几个维度，对吧？第一个是 transaction， 它 transaction 多与少。 PV 或者类似这种。
对
第二个呢，就是通过 CPU memory 去或者是 networking 的这个 I/O 的这个去判断，对不对？
对
我们可以根据你的这些我罗列的这种参数，有设定一个 threshold， 如果一旦过了阀值的话，就可以进行弹性扩缩容。
对，这个就它可以进扩充，但是说你们在哪怎么去管理？说我这个扩充是放在 Amazon 扩充，还是在 Google？ 还是
我们有一个 policies control， 就相当于说，当然也时间有关系啊，到时间我这个分享给大家吧。就是我们有一个专门接入公有云的地方，就是比如说阿里、Amazon 那边全部的参数你可以配到那儿，然后当你用的时候，我刚才说一个叫 fair sharing 的东西，我就可以去根据你的这个不同的需求，去定制你是从哪一个 resource 过来的，通过 policy 的方式。
对
啊，
好，谢谢。
没事。
谢谢，我们还有最后一个提问。OK，
好，那就先啊。
I want to ask for Mesos benchmark at Yum. We have not benchmarked Yum because Yum is the branch of Hadoop. We have similar functions, but we are more to serve other resources except Hadoop, include Hadoop. We have a function, but we have not benchmarked. And the Berg is really focused on the resource management. So, can you share Young Systems detailed performance? Because I have just a limited time, I just tell you this way. 1.5 years ago, people are comparing Young and Mesos, what problems they could solve. I can tell you that Young, it is created to serve Hadoop, but it's come to the market a little bit late. So, in the later, when we talk about resource management, the timing was not correct. And in terms of the performance for resource management, two products are similar. But in terms of the extensiveness of utilization, maybe more on the Mesos side. But there is no really better or worse.
那我在最后说一个，就是
One thing to add, Mesosphere started our business in APAC since the February of 2017. So I am like the first people here. So we are also recruiting the talents to build our own ecosystem. So we welcome all the interested persons to join our team. Thank you.